This is lesson 18 for forces in motion, graphical addition of vectors. It goes along with our FM10 assignment. You will need protractors and rulers to complete this lesson as well as the assignment. Now, graphical addition of non-collinear vectors. We will complete these together as a class one step at a time. Note that you have examples 1 to 3 on your handout. Do them in the right order or you will work your way off the sheet. If you don't have a handout, well, then you'll have to do them on a sheet of graph paper. The purpose of these questions is the same as the last lesson. To merge a number of vectors together to find out what the resultant vector is. For example, if you were driving a remote control car on a ferry that is crossing the river, we could find the speed and direction of the remote control car relative to the Earth if we know the speed and direction of the remote control car, the speed and direction of the ferry, and the speed and direction of the river. Whoa, pretty awesome. The applications are limitless. These are the same examples we did mathematically in the previous lesson, so we should get answers that are very close if we have done everything accurately. First example says we have to draw a vector going 2.3 meters north that is then added to a vector that's going 3.6 meters south, 26.4 degrees east. So we will start by drawing a vector 2.3 meters north, but meters might be a little long for our paper, so we are going to do a conversion and say that every centimeter on our piece of paper is equal to 1 meter. So we're going to go up 2.3 centimeters. North is up, so 2.3 centimeters up. So we'll take a ruler, and from our little dot, we will go up 2.3 centimeters. Ooh, fancy. Now I have to, this is tougher. I have to go 3.6 centimeters south, 26.4 degrees east. So since south is listed first, I'm going to have to line up my protractor so that 0 is on south. And I'm going to have to open it up so that it is facing east because I have to measure 26.4 degrees east. Right, so I've got my protractor set up so that 0 is directed towards the south. Then I'm going to measure over 26.4 degrees towards the east. And then I'm going to make a little dashed line because that is going to be the direction of my next vector. And I will draw that vector 3.6 centimeters long. So I'll start it where I finished the last vector, and I will draw a line that is 3.6 centimeters long. Now my resultant vector is going to go from where I started to where I finished. Now I'm going to get my ruler. I'm going to measure how long that blue arrow is, that resultant vector. And that comes out to 1.8 centimeters, which according to our scale would be 1.8 meters. Since it's a vector, I also have to include the direction. This vector is going south and east at the same time. Now use your protractor to measure the direction of the resultant vector. This can be done one of two ways. Since the resultant vector heads southeast, you can line your protractor with 0 degrees facing south and count the degrees from due south towards the east. So line it up with 0 on south and measure the number of degrees from south towards the east, which is 60 degrees. So 1.8 meters, if I face south, I go 60 degrees towards the east, and that gives me the direction of the vector. Or you could line the protractor up with 0 degrees facing east and count the degrees from due east heading south. So I set up the protractor so that east is at 0 degrees, and then I measure from 0 degrees towards the vector, and that takes me 30 degrees towards the south. So the other possible answer is 1.8 meters long. Direction is east, 30 degrees south. Now example 2, 3.7 meters west, 36.4 degrees south, subtract 3.0 meters north, 48.0 degrees west. And we're going to start this the same way that we did the questions in the last lesson. If we have a negative vector, we're going to change that negative vector to a positive. And when we do that, we have to change the directions as well. So 3.0 meters north, 48.0 degrees west becomes positive 3.0 meters south, 48.0 degrees east. Now we're going to start by drawing that first vector. So you need to start by using your protractor to determine the direction of the first vector. I'm going to place my protractor right on that dot for example 2. And since the first direction listed is west, I would line up the protractor so it's going east to west and then have it open towards the south. I'm making sure that west is at 0 degrees. And I'm going to measure over 36.4 degrees towards the south. I'll make a dashed line so I know where my vector is going to go. Then I'm going to take my ruler and I'm going to draw a line that is 3.7 centimeters long. Now I have to draw my second vector. So I'm going to take my protractor and place it at the end of the first vector. From the tip of this vector, you need to use your protractor to determine the direction of the next vector. Since the first direction listed is south, I would line up the protractor north-south and have it open towards the east because I'm going to be going southeast. I make sure that south has 0. And I'm going to measure over from south, 0 degrees. I'm going to measure over 48 degrees towards the east. Now I'm going to put in a dashed line so I know which direction that vector is going to be going. Then I'll take away my protractor and I will take my ruler and I will draw a line that is 3 centimeters long. Now draw your resultant vector. It goes directly from where we started to where we finished. Measure the resultant magnitude with your ruler. So I'll get my ruler out and I will measure how long that blue arrow is. And I come up with 4.3 centimeters, which is, according to our scale, 4.3 meters. Could be somewhere between 4.2, could be 4.4. It could even be in between one of the millimeter lines, in which case you would want to go to 2 decimal places and then round to 1 afterwards. You have to measure the direction of this vector. Now use your protractor to measure the direction of the resultant vector. This can be done one of 2 ways. Since the resultant vector heads southwest, you can line up your protractor north-south, with south being at 0 degrees, and open it towards the west so you can count the number of degrees from south that you had to go west. So again, protractor is lined up so that south is at 0 degrees. Then I'll measure over from 0 how many degrees to get to that resultant vector, and that is 10 degrees. Or else I can take my protractor and line it up so that 0 is on west. Then I will measure over how many degrees from west I have to look towards the south to get to that resultant blue vector line. And that comes out as 80 degrees. So our answers are either 4.3 meters south, 10 degrees west, or 4.3 meters west, 80 degrees south. Our final example. Again, I want to start by changing any negative vectors to positive vectors. So our middle vector of negative 8.1 meters north, 32.7 degrees west will become positive 8.1 meters south, 32.7 degrees east. I'm going to line up the protractor east-west, since our first direction is west 48.5 degrees south. That way I can place west at 0 degrees and then count 48.5 degrees towards the south. So west at 0 degrees, and then I'm going to measure over 48.5 degrees towards the south, and then draw a dashed line. And then I will replace that with a vector that is 6.4 centimeters long. Now I have to draw my second vector, which is going southeast. So line up the protractor north-south so that 0 degrees can go on south, and it opens up towards the east because I will have to count 32.7 degrees towards the east. So south is at 0 degrees, and I'm going to measure 32.7 degrees towards the east, and I will put in a dashed line. Now I can get my ruler out, and I will draw that vector 8.1 centimeters long. Now to draw my final vector. I line up the protractor north-south, since the first direction is north, with the protractor facing to the left, as the second direction is going to be west. That way, 0 is on north, and then I will measure over 46.9 degrees towards the west, and I'll make a dashed line so I know where my vector is going to be drawn. I'll put my protractor away, get out my ruler, draw a line that is 5.2 meters long. Now I will draw my resultant vector. And that goes from where I started to where I finished. Now I'll measure the magnitude of the resultant vector. I take out my ruler, and it measures 8.8 centimeters long, so it's equal to 8.8 meters. Now I'm going to use a protractor to measure the direction of the vector. Again, this can be done one of two ways. The resultant vector is going south and west. So we either line up the protractor north-south and measure the number of degrees the vector is towards the west. So I line it up so that 0 degrees is on south. I measure over how many degrees from south I have to go to get to the blue line, which is 25.2 degrees. So my answer is 8.8 meters south, 25.2 degrees west. Or line the protractor up east-west and measure the number of degrees the vector is towards the south. So I'll line up the protractor so that west is at 0 degrees. I'll measure over the number of degrees to the resultant vector, which is 64.8. So my other answer could be 8.8 meters west, 64.8 degrees south. And that's the end of the lesson. Happy drawing. There is an answer key that has an overhead sheet. So we place the overhead sheet over top of the questions that you have done to make sure that you've drawn all your vectors correctly. Because when you look at the answer key and you look at the numbers that I have, if your numbers are different, which they probably should be just by a little bit, if your numbers are different by a whole lot, we'll want to figure out exactly why that is. And the best way to do that is to hold the overhead sheet over top of your vectors, and we can figure out which line was incorrectly drawn, whether it be not long enough, too short, or possibly in the wrong direction.